Hey everyone, welcome to the CITRIS Research Exchange. I'm delighted to introduce today's speaker. I have a few quick things. I want to say my name is Ken Goldberg, professor here in engineering, and I want to welcome everybody who's watching and joining us through the web. Unfortunately, we can't offer you lunch, but and by the way, if anybody's still hungry after you eat your sandwiches, there's a couple more in the back, so you can help yourself. I also want to say that on Friday, the I4 Energy lunch or talk will be on a really exciting topic related to Tesla Motors. The title is Bringing New Technology to Market, a case study on Tesla Motors sourcing strategy. And I also want to announce that the Big Ideas program is launched. So you have until November 6th, which is also the election, I believe, to submit your proposals. There's a number of really exciting different topics and ideas. So go online on the CITRIS site to look for the Big Ideas challenge. So without any further ado, though, I'm going to introduce Eric Paulos. I had the pleasure to meet Eric almost 20 years ago. And Eric is really interesting. What's not on his official, this bio they gave me, but I happen to know is that Eric is not only an amazing engineer, but he's also an artist. And he's been building cool stuff for a long time, since probably well before he took a motorcycle across Europe, a Ducati, and took it all apart and somehow shipped it back, then reassembled it. He's really a consummate engineer and tinkerer. He's built a lot of very cool systems, and he's also a member in good standing of one of my favorite art collectives, the Survival Research Laboratories, where he's made he's done some of the first lethal telepresence systems known on Earth with Mark Pauline. So Eric is pursued a range of interests. He's also married to the brilliant Jill Miller, who's a conceptual artist, and he had an interesting background because he started right here at Cal, did his undergrad degree, and then stayed on for his PhD, where he did a research in robotics. In particular, was a pioneer in telepresence robots and connecting robots over the internet. In the 90s, that's about the time I first connected with him. But then he went on to work at Intel, and he headed a research lab there that was looking at motes using sensors. The name of that lab was called Urban Atmospheres Research Lab, and he did a number of interesting projects there, and then he was attracted to Carnegie Mellon, where he became a professor and ran a lab there, and was also held the title of the Cooper-Siegel Associate Professorship, a chaired professorship there. And then that leads us up to about this time last year, when we started recruiting him heavily to come back to Berkeley. And I have to say that it was a fairly difficult process, because Carnegie Mellon didn't want to let him go. But we succeeded in the end, and we can't be happier, because now he's coming back. He's bringing all these skills and talents and resources and charisma, which he has in abundance, back to what he considers his home turf. So Eric and Jill moved back here. He's got an office up on the 4th floor. He's starting a new lab, actually a number of new spaces on campus, new projects, and I couldn't be more delighted to introduce today Eric Paulos.
Great, thank you, Ken. It's an honor to be back here. It does really feel like a homecoming. As Ken said, I was an undergrad and grad student here, so a lot of just great history. Just feels like a great place to be. Correction, it was a Moto Guzzi, not a Ducati, for the aficionados. Don't want to have some confusion. This is a big deal if you're in that world. So I'm gonna talk to you today about some of the work that I've had the pleasure of doing with some collaborators over the years, and to kind of point some visions of where I think the interesting kind of horizon is to look at. And as Ken said, I'm right here on the 4th floor, so please come visit me or contact me, and I'm happy to meet up and meet old friends and make new ones as well. So I want to start off with a little bit of a story. So some of you may not be familiar with this particular project, Operation Moonwatch. This is a project that around 1952, 53, basically Fred Whipple decided to get people to sit out and observe and learn how to observe satellites as they orbit the Earth. and he trained people. And if you're sort of doing the math in the back of your head, you'll realize that that's actually several years before the launch of Sputnik itself. So in fact, they were training for something that hadn't yet occurred. I think it's an interesting kind of vision, because in some sense that's what we do every day as researchers and technologists and practitioners. We try to envision things that don't even exist yet. The interesting thing is, of course, when Sputnik launched, it caught the world largely off guard. It was a huge political sort of issue at the time. But in fact, Fred's group was in position and, in fact, the best equipped to report on this and give real kind of live data about what's happening. And I think it's this nice indication of these kind of amateurs, essentially, doing things that have tremendous impact. Another photo, I know everyone recognizes this. It's the Supernova 2008 HA, right? The more interesting thing about this is to show you the discoverer of it. This is Carolyn Moore. She's a high school student at Warwick, New York. And granted, she has a little bit more sensing than you do. But that might not be so true. She happened to be sort of biased towards telescopes. You might be biased towards mobile phones, sensing in your phone, other kinds of maybe home devices you've put in, but largely that there's ways that technology and the new kinds of sensing and new kinds of lenses on our world have given us the ability to see and participate in really remarkable ways in science and in society. It's not just the sensing. This is Solar Center by Marcus Kaiser, and this is actually a project that brings together the abundance of energy and raw material. So it actually is a 3D printer using the sun to focus the sort of energy and actually sintering the sand, which is obviously the material in abundance. And you can create things. This is actually a bowl created with the solar center. And you see this repeated kind of emergence of people going out and making and building and creating things and participating in really radically new ways we haven't seen historically in society. And I'll come back to the sort of space story for a minute. And of course, we're all familiar with these grand challenges, put a person onto the moon and return them safely. And I think these are great sort of visions, and of course, people all sort of celebrated this, but largely the people that kind of executed it were the sort of brave scientists and engineers of the day, right? So, and I think we can have another debate, which is I think largely what CITRIS is really formed around, which is sort of where are the new opportunities? Is it healthcare? Is it famine? Is it the economy? Is it education? Is it literacy? Is it the environment? And we can sort of have some really critical discussions about that. And I think science is going to play a very significant role. But I think another sort of new element is that these expert amateurs, these citizens, will play a very significant role in helping solve these problems and helping participate in different kinds of ways of solving them, essentially. And I'll come back to this term micro-volunteerism in a little bit, but this is sort of foreshadowing of that. And I think most people get this. I mean, this is Ilona Ostrom, who won the Nobel Prize a couple of years ago. She said, bureaucrats sometimes do not have the correct information, while citizens and users of resources do. And just about everybody gets this. I know my bus. I know my park. I know my kid's school. I know my neighborhood sidewalk situation, or if you're in Pittsburgh, when they're plowing, all these kind of different issues. And I think it resonates, and it's a way to engage people in their kind of environment. Now, one thing's different about these problems than sort of very traditional engineering kinds of problems. They're actually what they're called wicked problems, which coincidentally was a coined term here at Berkeley in the College of Environmental Design by Horace Riddle, where they're these societal level problems. And they actually are very challenging to sort of solve in traditional kind of engineering approaches. They involve engineering, no doubt, but they really lend themselves towards these kind of hybrid approaches. So I'll give you an example. So if we decide maybe let's try to solve street crime. So I don't know, we could disarm the police, okay? Then that could possibly solve it. We could repeal the laws, so actually change the definition of crime. That's also a solution because we've kind of redefined that's not a crime. We could substitute some kind of self-ethical kind of control around people. We could just shoot the criminals. That would be another way of solving it. And I think you see that we could also just give things away. We can disincentivize the entire problem. And I think people, we'd have to sort of somewhat agree, I think, that these are solutions in that they do provide some kind of measurable change in the original kind of solution set of sort of street crime. But in themselves, they really lend new problems and new kinds of sort of difficult social situations to deal with. But I think that one of the things that CITRIS and Berkeley has really kind of leveraged throughout the years is these really expert practitioners around campus from engineering and from the humanities and arts and design, other places. So one thing that is an interesting tool to use is design research. So this is a little bit different than design in terms of designing actual products, like an iPhone or in a Dyson vacuum or something. Design research is an inquiry focused on producing a contribution of knowledge, okay? So, for example, these are some terms you might be familiar with design, sort of problem solving, different kinds of producing products and things. And these are sort of terms I would more associate with design research. And just to pull out a couple of them, again, things like instead of problem solving, you're often problem making, explicitly to generate some kind of debate and move the kind of agenda forward. Things such as looking at consumers, you might be looking at citizens, or thinking about how to get people to buy things, you might want to think about how to get people to think. And these are this is a mechanism to move along that kind of trajectory. I'm not going to offer some definitive definition of design, but I particularly like this one. Design isn't everything we make, but it's also between those things. It's a mix of craft, science, storytelling, propaganda, and philosophy. I think it really sort of touches on a lot of the kind of human element that we encounter every day. Now, as Ken said, I originally worked for a while at this Intel research lab here in Berkeley, and I ran this group called Urban Atmospheres. Some of my collaborators and some of the groups that kind of crossed over during this time are listed here. And it was largely to look at urban spaces and deconstruct the kinds of activities that were occurring there and look for opportunities for where technology would emerge in really interesting and perhaps provocative ways. Now, I'm not going to go into these projects in detail, but I do want to kind of show in broad strokes that some of them look like things you might expect, mobile phone applications. But some are trash cans and park benches and matchbooks. And we really like to make and build physical things that are functional pieces of technology that play into this design research critique. And that's largely the thing that also lends itself towards the Berkeley Center for New Media, which is really in a position to kind of be a leader in that kind of area. Now, I'll tell you about one of them just briefly. And this was a project called Jabberwocky, and it was really looking at this idea of familiar strangers. So familiar strangers are people that you see every day, but that you don't really talk to them. So it's that kid that's always riding a skateboard in your neighborhood. It's the lady that's on the bus with you. It's that older gentleman that's walking his dog. It's a real relationship. It's a relationship in which you mutually agree to ignore each other without any implications of hostility. So if you ignore your friend, you're probably mad at them. That's actually a message. So we looked at this situation, try to understand what was going on, and I'll sort of cut to the chase. We did a lot of different experiments and obviously some research that came out of this. But one of the things was that we designed these kind of mobile phone applications that let you visualize the kinds of people around you. If it was, for example, people that had been to a cafe that you'd been to recently, or the kind of how many people had been to similar locations. And we're really playing around, and this is before Friendster, this is before a lot of the technologies that you're familiar with. And we're trying to understand how people's perception of place changes. And I think it's clear, about 8 or 10 years later, now all of us kind of feel like, well, that's normal stuff that we have on all of our devices now. But the interesting thing is, people were asking, how are you able to kind of come up with that idea before any of this? Like, none of this existed at the time. And this is what I think is always the challenge. And we always often get it wrong. That's part of our job, to get it wrong a lot. But I wanted to think about this a little more critically. And when I did, and this was work that I'd done with Elizabeth Goodman at the time, who's actually in the iSchool as a PhD student now. One of the inspirations was Stanley Milgram, who had actually looked at this concept of familiar strangers. Same Stanley Milgram that did these obedience to authority experiments you might be familiar with. He did a lot of other interesting ones. But even more so, even artists. So Vito Conci, who has this project called Following Piece. Basically, you find someone you don't know in public, and you follow them until they go into a private space. So this performance can last a couple minutes if they get into a taxi cab, or hours if they go into a theater. I don't guarantee you won't be arrested doing this, but you're welcome to do this performance on your own. But it got me thinking a little bit more about this. I mean, similarly, with my advisor at the time, John Canny, when I was here, some of the PhD work, as Ken alluded to, was looking at telepresence. We did these flying blimps. This is one of them actually in the Waz here, so you'll recognize it. I don't know if they've changed the carpeting recently, but you know, probably same furniture. But this was in the sort of mid-90s, essentially, and it was allowing people to kind of interact with these telepresence and have a remote presence. And we were looking at lots of social issues around this. And when I thought about this project, it really was clear that, of course, it was inspired around how people would have a kind of physical interaction across a distance, the quality of that interaction, a lot of things that were going on in kind of computer-supported collaborative work. But at the same time, it was really being inspired by artists. Andy Warhol, who had done the Silver Clouds, and a lot of projects that looked at these kinds of spaces and the way people moved around. Now, I realized that I thought a little bit deeper, this was actually a lot of projects had this sort of reference point. One of my favorites was Michael Neymark, who did this Aspen Movie Map back in the 70s. And he created this project where, this is a laser disc, ladies and gentlemen, a laser disc on this, where you could actually cruise around the city of Aspen and you could navigate it. And clearly, it seems very much like something else I've seen, you know, in the last 5 or 10 years, Google Street View. And it's not to say that we wouldn't have Google Street View if Michael hadn't have done this, but Michael did this as an art project. And in fact, even the setup that he used was very similar. This is his and this is Google's. Michael got a really interesting award for this. For this, he actually got the Golden Fleece Award. So I'm not sure if people know what that is, but the Golden Fleece Award is given to the most egregious waste of taxpayer dollars. Okay? So back in the 80s, this was the most egregious waste of taxpayer dollars. This is something else. So I'm not saying, again, that Michael's solely responsible for this, but I do want to highlight that often artists can inspire us and get us to question things that will eventually become real kinds of landscapes and technologies we live in. Here's just a couple others. Myron Kruger, an art piece. The Video Place looks a lot like iToy and a lot of the things you see for Connect and the Wii. Legible City that Jeffrey Shaw did looks like a lot of fitness kinds of equipment that you can buy today. I was just having fun one night putting these together. TerraVision and Google Earth. Those of you that watched the Tour de France might have seen the Nike Chalkbot. Well, it looks a lot like the graffiti writer. Okay, so again, we see these kind of connections. Similarly, Hiroshi Ishii and Maggie Orth did some work with Tangible Media Group on these triangles with kids. Looks a lot like magnetiles. If you have kids, you know what I'm talking about. Or things that are even a little bit more recent. We've got Twitter that looks a lot like a project called TextMob by the Institute for Applied Autonomy. And it's not a coincidence. Jack Dorsey actually said, oh yeah, well I looked at this and I said that's what Twitter should be. So he actually draws the distinction really, really tightly. Now, the problem is when I thought about how hard it is to envision these things, I realized I went back to the telepresence work that John Canny and myself were doing in the 90s. And this is what was sitting on my desk. So if I had the cutting edge Pentium at the time. I had just installed Mosaic. I was cruising around using Alta Vista. If you were doing any social networking using the Well, maybe you're using Usenet, that was really what was available. And I think John was a nice advisor and had coughed up some money, so I had a Palm Pilot, and I was just really rocking out. But to envision from these raw materials what the kind of experience that you would have here was a big leap. And I'm not claiming that we get it right all the time, but I do want to point out that sometimes you have to take these really large risks to kind of envision what these are. And these were these props that were personal roving presence devices, mid-90s, that allowed people to kind of interact over a distance. And a lot of you have probably been watching the news, and you see a lot of things that look a lot like something. This here is a 17-year gap until these appear. So there's a little bit of a difference in that. More interestingly, these are the applications that we were talking about at the time. Maybe you'd do remote manufacturing, maybe you'd hang out, maybe you'd use these tablets to control things, and here's actually on their press release what these look like now. So we got it pretty close. There's definitely made some side steps, which I would claim they're the ones that didn't do it right. We had it right a lot of the way, but some interesting things. Coming back to the other applications with some of the telepresence with these flying blimps, I thought, well, now this is really cheap. You can buy these blimps. Everyone who's been on an airplane has looked and flipped through these crazy, in-flight magazines. You can get these for $19. Everyone's got some kind of mobile device with some sort of two-way video and audio. Maybe you could download my entire thesis for 99 cents as an app, and for $19.99, you get something that took me years and years to do here at Cal. This was depressing. Then I realized this is actually very cool, because in fact, I thought that is really exciting that something has really kind of come together in that way. And in fact, it was the fact that these things are really low cost and easy for people to do that also got me excited. So this whole idea of the kind of rise of the expert amateur, where we have people, as I mentioned, the Solar Center, here's a low-cost DIY sort of PCR machine for doing DNA replication. It's a concept 3D printer for children's toys. But essentially, we're moving from proprietary innovation to populist innovation. And anyone who spent time on Instructables or Make knows these kinds of things. And that's really been inspirational for the way that I've looked at the world and tried to kind of innovate. So I'll do a little bit more deep dive into some of the projects in the research group that I most recently have been running, the Living Environments Lab, which is looking at this kind of critical intersection between humans, the environment, and technology. And these are just sort of more themes, and again, I won't be going through all of these themes, but I will hit on a couple of them, most notably citizen science and some of the energy work. And these are some of the students that I worked with at Carnegie Mellon, Stacy Kuznetsov, James Pearson, Sun-Young Kim, and they're largely responsible for most of the work that's kind of coming here. So let me just go back to citizen science, and we already looked at Operation Moonwatch. One of the canonical examples is these kind of Christmas bird counts where you go and you count birds, and people say, well, I'm not really qualified to count birds, but in fact, by having the kinds of people that are essentially untrained as amateurs, in fact, ends up building this world's largest sort of migratory bird data set that's really useful to scientists. What I think is more interesting is that what I like about citizen science is I think it taps into this childhood curiosity that we've all had and somehow we often forget about. And that is, I want to find the strangest bug in my yard, or where is the rock with the weird crystal, or when is that grasshopper going to jump off of that leaf? And there's sort of this idea of being curious about our world. And I think one obvious opportunity is we always build essentially lots of our tools, and especially mobile applications, to say, how can we sort of, in some sense, make our experience of the world more efficient? And it's not to say those aren't noble applications. I'd like to be able to get to the bus on time. I don't want to miss BART either. I like to find a hip restaurant when I'm in a town I don't know. But I also think there's opportunities to say, how come our mobile technology can't make us more curious, make us wonder about our world, make us be more reflective? And I think those are the interesting opportunities moving forward. And it's really thinking of that mobile device. Of course, most of the younger generation has already figured this out, but it's not a communication tool. It's really this kind of, supercomputer radio station with sensors that you can start to do all kinds of sensing and new kinds of interactions beyond just talking, right? And citizen science is no way I can kind of give a complete gestalt picture of all of the projects. These are some of them actually that are at Berkeley largely. Most of you remember SETI at Home, one of the early projects that let people kind of collaboratively work on data sets, and a number of others that have been done here. Foldit was actually at Carnegie Mellon and at University of Washington, actually. But that people can bring together kind of amateurs and through this interface train each other to sort of solve bigger problems. Now, one thing that's interesting, I think, about citizen science and why it's worth pursuing is these kind of four key things. One is, I believe it can improve the science literacy through people's active participation in it. So you're actually doing the scientific method. You're saying, I wonder if I have the strangest bug in my yard, or the most ants, or the worst air quality. And then people can go out and kind of collectively, as a crowdsource, do that and come to some result. But I also think it can provide sort of stakeholders and actual decision makers and civic leaders with some kind of information to make policy decisions. we're also talking about creating really new experiences for mobile devices. So now if you might come across something in your environment and you think, I wonder if that's true in other cities, you'll think about how you can use your mobile phone to answer those kind of questions. And I think that's a literacy that will come up through even early childhood education. And sort of finally creating a better awareness of the environment. I mean, by being, in some sense, the applications I'm talking about don't invite you to be kind of buried in your technology. They invite you to be looking around and exploring your world. So I'll give you some examples. Some work that I did early on with some folks. This is largely Intel research with Alison Woodruff, Paul Aoki, R.J. Haneke, and others, was to actually go out and collect data on air quality using sensors. So the picture on the right here is of Accra, Ghana. And this was, we gave basically a number of taxi drivers and students some sensors that collected various properties of the gas, like carbon monoxide, various other, we had ozone, a number of other things. You're looking actually only at, I think, the carbon monoxide levels. And the main thing we wanted to do was just say, hey, what would it look like? Because as you know now, if you want to know what the air quality is, even for the Bay Area, it's largely kind of one number. It might be sort of somewhat gridded by areas. But as you can see in this heat map visualization, it varies a lot by actual intersection and time of day and a lot of other factors. And largely, we just wanted to get this data set and start to talk about what that meant to have amateurs essentially collecting the data. This is a different kind of version using a mobile phone. But what became more interesting, actually, was when people turned in the devices, they started to talk about their experiences. And again, this wasn't part of the actual experiment, but they would say, hey, I actually realized it was really bad air quality in the afternoon, so I would always go around the ring road and then come into where I needed to be. Or someone would say, actually, I'm wondering if my car is actually part of the problem. And he brought his car in to have it checked out. So this, just by having this visualization of something they couldn't normally see, they started to actually talk about it more and engage in kind of a more proactive way of thinking about what that meant for the environment and their health. And I kind of call this the Prius effect, right? So you've maybe all been behind that car that's trying to get to that 100 mile per gallon holy grail as they're driving, right? But largely, once you give people this data, they want to sort of understand how it varies and how it changes and how their behavior affects it. So we've done a bunch of other kinds of experiments related to this. So we looked also at not just the personal mobile experience, but what about, say, a fixed experience where we put these sensors into people's homes? And much like you might imagine knowing if your friends are online or what they're listening to or what they're tweeting about, this was letting you see what their air quality was in their home. How many particles, actually, this is a particle count. And it was interesting first because people didn't have any privacy issues with sharing particle count information about their homes. And interesting kind of dialogues erupted around this. People would sort of say, you know, someone would go way up, they'd call them, they'd say, yeah, I burnt something on the stove. People realized if they opened and closed windows, different kinds of effects occurred. If they vacuumed, what happened? And then some really interesting side effects, again, not part of the study, but there were 2 individuals that quit smoking as a result of this because they saw how high their level was in comparison to everyone else. And also infrastructure in public places. Let me just say a little bit more about that. So we also want to think about how the city and municipal vehicles could play a role. As great as people are, we kind of sit indoors a lot. But things like street sweepers and mailmen and different kinds of like parking meters, individuals, they actually move around the city a lot. So we actually worked with the city to mount some sensors onto these street sweepers. And that let us collect a lot of data. So with maybe just a dozen sensors, we could cover the entire San Francisco area every couple days. And this is some of the things that we were sensing and mounting these on here. And we did the obvious thing. You could put them on maps, and you could build up these pictures of where the sort of air quality varied and what was happening. And there's some interesting things about, some of it's pretty intuitive. You know, actually on the highways, this is 280, you get you know, lower air quality than in other parts of the city. And it had some other nice properties. They all parked together in the same kind of corral so we could cross-calibrate them in the evening. So I'll say something about the community-based sensing. So this was a story where we said, let's give sensors to different communities and intentionally not give them enough for everyone. So they'll have to kind of negotiate what to do with them. So this is with bicyclists and parents, activists, and the homeless community. And we wanted to see how they moved them around the city and how they positioned them, what they wanted to collect, what they wanted to say as a message. And they all did very different things. This, you probably don't recognize because these were done in Pittsburgh. This is Pittsburgh, and you can see how people moved it around. And the main thing was that people wanted to do very different things with it. They wanted to do a very different message. Parents, obviously, near schools and playgrounds. As the activists wanted to sort of really spread it out and have more of a story about the whole city. And another interesting thing, which is we talk about how great is it going to be when we really have ubiquitous computing every place. And in fact, the message was that, well, once you put these technologies out, if they don't look like a mobile phone, they look like a bomb. So, and I knew this was going to happen, but continuous calls from the Pittsburgh Police Department about these, of course, had our name on it and things like that. And we had sort of intentionally designed them to be a little bit odd, admittedly, but it brings up the discussion, should these sensors be invisible? Should they just fit into the landscape? Should they be black boxes with a red flashing light? Should they look like a teddy bear? What should these kinds of things look like? And that's an interesting kind of form factor design study we're also looking at. So we're also interested in how these, we have these map representations and graphs, and we've done a number of those, but we are also thinking of other ways you might encounter this data. So there might be new kind of signage in the city, not the shortest route, but the cleanest route. We might have actual clothing. So this is a t-shirt that Sun Young Kim, one of my graduate students, did that actually measures and responds to the air quality around you. Now this is really different because you can imagine walking into Triple Rock with this, and someone's like, wait, what is that? And they go, well, go outside. Well, why is it different outside? Wait, go over to Spats or move around. And so you become part of the kind of dialogue of sensing. It's a very different experience than holding a personal kind of mobile phone. These are just some pictures and some other kind of representations of playing with various signage in the city. Right? But we're interested in generating what feels right. And we've actually done studies of this that I'm not going to really go into, but largely how people gain a different kind of reflection based on the kind of way they experience the data. And these are just some really low-cost versions where we really try to push down the bill of materials around sort of $15, $20 for some of these sensing technologies to see what you could really do and still get a kind of signal. And similarly, we said, well, this is some work that Stacy Kuznetsov did where she said, what if these sensors could actually move around? So this is actually a little magnetic robot, so you could throw it on a pole, it can run up the pole, take some measurements, come down, you knock on the pole, it can kind of know to come down, and you can interact with it. And it's also a little bit of an interpretation of maybe a different form of kind of public objects. So maybe not graffiti, but maybe these are objects that actually go and they participate in other kinds of measurements around the city. And then finally, another sort of low-cost experiment in this area, and this was, again, work by Stacy, looking at what we're calling sort of spectacle computing. So often we talk about how computing wants to sort of disappear in the background and maybe not be so visible. But in fact, there are reasons you might want to overtly draw people into a particular public debate. So these are balloons that are lit up based on different kinds of gases and particles they're sensing in the air. So the experiment was we built a bunch of these in sort of a DIY fashion, and then you could imagine people came up and said, what's this glowing balloon? We sort of explained briefly what it was, and now this person, again, is walking around, and they become really part of the spectacle. They're like, I want to bring this over to my house. I want to bring it over to my kid's school. I actually want to bring this into work. And people start to ask them what it is. So there's interesting ways to bring people into these discussions about different sensing strategies. I don't think sensors always have to look like a sensor, so to speak. I want to question what a sensor even is. So some of my students also looked at biomarkers and this idea that, in fact, sensors don't always have to be digital-powered things that look like sensors. In fact, the natural world around us is full of things, if we look closely, actually tell us a lot about the environment, the kinds of situations that are occurring in terms of pollutants and soil and air. And this is a little bit more recent work that Stacy's done looking at actually how you can do these DIY kind of bio-experiments with these Wittogradski columns that actually measure the level of different metals into the soil. So I want to come back to the idea of this micro-volunteerism for a minute. And that's that often we think about how we might volunteer. I mean, it might be, perhaps we do a beach cleanup over a weekend. Maybe we do, Habitat for Humanity, and we actually spend some time over a series of months. Maybe we volunteer for the Peace Corps for a couple years of military service. But the real opportunity, I think, is what does it feel like to volunteer for just I'm at the corner of Hearst and Euclid. I have 22 seconds. What can I do? Right? So that kind of application is interesting. And it's really tapping into this cognitive surplus. I mean, right now we might check in on Foursquare, or we might tweet something, or we might check our email. But there's other opportunities, if we design them right, to have that experience. So this is the kind of classical citizen science mobile phone application. Susan sees these particular beetles that are attacking these trees she's concerned about. She takes a picture, she uploads it to the citizen science site, and the kind of person managing the campaign says, great, thank you, we will now marshal our forces and solve the problem. Some things do work like this. But every time we do one of these, and we've done various versions of this, someone says, that's very cool, I don't care about the beetles. I care about idling buses or something else. So what we're trying to do is say, well, what if someone could actually say, Susan wants to say, well, I actually want to compose my own campaign. I want to ask for particular kinds of data from a particular area, from different kinds of people. And she can publish this, and people can kind of subscribe. So the same way, when you visit a city, you land, you turn on your mobile phone, maybe you go, hey, I wonder what campaigns are available here that I could get involved with. I'm here for just 2 or 3 days. Or if you live in a place, of course. And likewise, how can the data sets be sort of debated and discussed, much like, of course, people like Susan might want to answer particular questions, but maybe stakeholders and scientists and other policymakers have other kinds of questions. So that's kind of the interesting landscape. Now, the other opportunities that we're really interested in are the idea of sensor flexibility and context. So we've talked a lot about air quality, but perhaps if we start the story in the Central Valley of California, it's more about pesticides. Or if it's back in Pittsburgh, where I just came from, maybe it's more about the fracking that's going on and the water quality. So there could be lots of different issues. So the idea of how people are going to move between those contexts and these sort of ways that the devices will change and the sensors will change. Another missed opportunity is this idea of not just citizen sensing. So we've talked about how people could collect data, like sensing things with sensors or pictures or microphones, but also citizen analysis. So very much like something like SETI at home, where, for example, say that I'm actually very concerned about the fracking that's going on back in Pennsylvania. But I'm not going to really be able to measure things directly here in Berkeley. But I'd like to be part of that community. So could I be also a sort of citizen analyst? Can I be part of that community and I can help analyze the data? So that's a kind of another missed opportunity. This idea of foregrounding contribution. So most of these are exciting to do, but I'm not convinced that they'll be exciting in week 52. It'll just be kind of disruptive and boring. One thing that's to certainly incentivize that is letting people know, hey, the EPA downloaded your data. Hey, we changed the 52 bus route because of some data that you've contributed. Just different ways of letting people know that they're actually part of this bigger data set. Badges and rewards. Again, I wouldn't have believed it if someone told me 5 or 10 years ago that people would care about these little icons, but they're very cool and people do. But I think it can be expanded. Right now we talk about maybe being mayor of a place. But what about if you're the citizen scientist of a place? Or you've just unlocked a microclimate because you've actually downloaded enough data or contributed something. Or you're, you can have these different kinds of badges around, you're the mayor of, Strawberry Creek or something like that. Really using games and play in an interesting, creative ways. I think one way you could imagine is, so these are these pervasive games where the game is actually physically moving around the landscape or the city or the country. And so, for example, just say that bees, for example, is part of the interesting game space. There's these virtual bees, and you can collect them, or something is going on. But in fact, the bees are really just a representative of pollen counts. So you're really learning already about where the pollen counts are and how they change and vary with different kinds of atmospheric conditions. And maybe you say, I want to put some of my bees in the game. So you collect data. the pollen counts, and suddenly you're participating in this really interesting way. Maybe that's where you're going to actually be, but in fact, you may scaffold up and become a more kind of different kind of contributor to that. Also, I mentioned these sort of biosensing technologies, but I really new form factors for what sensing is. So why couldn't we have soil sensors on children's toys or on, strollers or clothing and some of the other examples that I showed? And it's not to say that they have to be sort of overbearing and it's really scientific in the way that I think most of us would think of them, but have them be playful and have people think that it's lots of things we would expect to find sensors in lots of places. So the last story I'm going to tell you about is this idea around energy. So this is work with James Pierce, one of my other graduate students, and it's really rethinking what energy could be in a pretty significantly new way. So right now, all of us we plug into the wall, we get electricity, it's uniform, there's a very good reason for that, and that's something that we don't have a problem with. The issue is, can you think of energy as a material, as having these kind of properties that you don't usually think of? And I'll tell you an overly sappy story because it kind of gets the point across. Here's my son, Paxton, and he's swinging. Now, if he went out and he was swinging today, and he collected a little bit of energy, for example, and he stored that, and tonight, he brought it home, and we were able to sort of read a book to that light. The question is that different than plugging into the wall? So I would claim, yes, it's a gift. It was handcrafted. There's emotional content. It has sort of different textures to it because it's the way it was sort of created. It's the aura, if you were kind of thinking about the Walter Benjamin kind of framing. It's essentially something that has this very loaded content. We don't think of electrical energy that way, but there's no reason that we can't. Usually we're looking at, when we talk about energy conservation, we're thinking about, okay, how are we using it? How can we reduce the way that we consume energy? In fact, we did a survey of, I think, around 70 pieces of really recent literature around energy conservation, and actually 70% of them look at only this kind of energy feedback phenomenon. But we do a lot more, right? Energy gets produced, we keep it around. We could imagine sharing it. These are things we don't usually talk about. The same way if you're over at a store, you might take a penny, leave a penny. Would you get off your bus and say, I'm going to leave a couple joules for my fellow passengers as little bits of energy? So these kind of small bits of energy, can they have this kind of meaning? And this is not that far-fetched because, of course, people already do this, right? They collect energy at their home. They just put it back on the grid. But could you imagine someone having policies like, I like to give this back to my neighbors, other families, people in particular housing situations, other people that are bike riders, something like that. And this really plays into the kind of grid OS and some of the low-cal work that's been going on here at Berkeley. And we've done a lot of different projects that kind of try to play into this theme of looking at different textures of energy. So almost a seasonal energy lamp that's reflective of the kinds of energy that are available to you at a given time. Or similar, there's an energy monitor that gives you feedback about the kinds of energy that you could use. You might think about how you would use energy differently if you saw these kinds of prompts. So not just how much battery, but what's the composition of that? If you go to different places and charge up, you would learn about the kinds of production of energy in different parts of the world. So in some sense, the same way we might talk about food, it's fresh, it's local. Could we have fresh energy, local energy? It's something that's, hydroelectric or, different properties of it is an interesting concept. Now, we also ran some experiments talking to people about these devices. And they basically do the same things, but consistently people talk about the ones that are on the right as so much more authentic and genuine, that's more in touch with the material. It's something that feels as if you're actually doing the particular action. And so we thought about how energy production can have those same kind of qualities. One thing we've talked about is these energy mementos. So this is, again, on the emotional side, but it gets the point across, can you have little small bits of energy? Now, to be clear, small bits of energy does not an energy crisis solve. But small bits of energy certainly generate new ways of thinking about them, new ways of collectively coming together and using them. you could say the same thing. You know, little tweets do not sort of, you know, create any big change, but collectively they certainly do. So again, could you imagine you and your father perhaps cranking this crank, and would you put it on the shelf? That's the energy from my father. You know, is that the way you think about it? You know, you went to New York and you got some wind from the subway tunnel and you kind of had that and said, hey, I brought you this back from New York, some wind energy from the subway. And again, we built some technologies to actually sort of do this and extract the kinds of qualities that we're interested in. And the technologies are there. This is not sort of made up per se. It's things that actually work. And I'll end with something that's a little bit more provocative, but it's intentionally looking at energy from a parasitic nature. And this is a project called Energy Parasites that I just showed at Ars Electronica recently. And the idea is, again, to think about small bits of energy, but rather than a little bit of the more poetic story I was telling earlier, these are intentionally designed to look very homemade, sort of scavenged parts because they're scavenging energy. And they're positioned around different parts of the city that people can put them and collect energy, and they could either waste it if they want, or they can actually decide to, you could actually charge your phone with this. You can literally run this around sort of a tram around town and then charge your phone. So you have tram energy that you have on your phone. And this is an example of the kind of full spectrum of this. So things such as, again, on a tram, on the railings of a escalator. And again, this is not free energy. You're actually stealing it. You're actually taking ownership of it and reusing it in a very different way. A water fountain, putting it onto a headlight to extract a little bit of energy from someone's headlight as a solar panel, and then taking it and then reusing it in a very different way. So hopefully this kind of paints a picture of the ways that at least myself and my students and collaborators like to look at the world and produce objects and have sort of discussions about them. Here at Berkeley, I'm hoping to obviously play a role in citizen science and also these kind of collaborative consumption models, things around DIY culture. We're looking at sort of setting up a kind of a lab that will allow people to be kind of like a fab lab where individuals can actually make and build things. And I'll be teaching a class on some of these technologies and sort of methods next semester. So with that, I'll end and thank my students.
That was a great talk. Do we have any questions from the audience? All righty. Oh, wait, sorry, can you use the mic so everyone can hear you?
Why not just charge your phone from the tram electricity power directly?
Right, yeah, no, I mean, there's issues of, I like that one actually. It was just an issue of kind of hanging things up there, and you could imagine throwing something across the third rail. I mean, at some point, it was trying to run a fine line between not disrupting the actual service, but you're thinking the right way of not only, there's an issue of kind of efficiency, but there's also an issue of these objects that I showed at the end, the energy parasites, they also articulate places and opportunities where energy is kind of seeping out and we can kind of recapture it. So even though there's a little bit of a sort of strange story about stealing it and it's really not efficient in any way, it's also, there's a kind of embedded hopeful message of, well, what if we rethought where these little bits could be collected? And again, but you're right, you could imagine taking it from, you know, lots of different places, but it also demonstrates different technologies. So even, you know, a car, you know, changing an EMF field as it moves. I mean, there's like little bits you can actually take piezoelectrics and just kind of rub them. You get some energy out of just like this. There's all these little tiny things, and it's true you can't do that much with them, but you can do some things. I mean, these will like light up and make noise and do some kind of interesting stuff and drive small little motors. But again, this is more of a kind of art project to question that. But yeah, you're right. You could. I like that thinking for sure. I've always thought it'd be cool to like build your own car and just hook it up to the Muni and just drive. Like, why can't I use that power on there? Like, well, probably because you're not allowed, but still be fun.
Did you have a question? Okay. No? If we don't, oh, we have a question over here. Okay, hang on a second.
The way citizen science has been described here, it's more focused on answering questions which seem of importance to scientists and policymakers. But one of the things that's coming out of, say, the quantified self movement is a lot of people are using the sensing capability to answer questions of more personal importance. It's a more of a bottom-up definition of citizen science. But what are your thoughts on that?
Great point, by the way. So, yeah, I actually, to be honest, I have a problem with the term even citizen science. I mean, I'm sort of struggling with it myself because it has this embedded kind of science. And it seems even the projects that we've done, they err on the side that other people think, oh, I have an idea, but mine's not like scientific enough, so I don't want to participate. It's actually excluding a lot of really interesting ideas. So at least some of the thinking, and I'm not claiming we got there, but with thinking what sensing can be and some of the context and even people forming their own campaigns, that the bar would be, you know, yes, someone could say, let's collect, you know, air quality data around idling buses and actually improve the health of people, but also some kid can say, hey, I got more leaves on my yard, like I'm counting them. Like that should be equally sort of accessible to people. So it's almost the burden's a little bit on us to try to articulate. There's other ways for people to engage, and it doesn't have to feel so kind of heavy-handed. I don't know if that answers your question, but I definitely feel that it should feel more of a kind of experience. That's why rather than citizen science, I almost think micro-volunteerism. It's just getting people to volunteer in little ways is kind of a better way to possibly think about it. Yeah, but quantified self, it's another good example for sure. So thanks for that.
All right, we have time for one more question.
Yes, I very much like the way you showed how you can create some consciousness for the things that are invisible in the normal world, but you can also use that to hurt somebody. For instance, if you take hydrogen cars or electrical vehicles, and it said they're emission-free, but they're not. So are you afraid that maybe some people will say, well, let's show that actually an electrical car is not solving any energy problem?
Right. So this is a good point. I'm convinced now that any good technology has a really dark side to it. So even, you know, of course, the maps we generate with air quality, I can also go around your house and report really bad air quality and drive down the price of your house and real estate in your neighborhood and do these kind of bad things. And it's true, people can obviously come to the wrong conclusions on things. So I apologize, I sort of glossed over it, but this issue where I was trying to show the way people might represent data and sort of debate it. So collectively, the idea is get people involved in that process so that they can say, hey, if you look at it, electric cars are actually horrible. And then someone says, no, actually, if you look at this other data set, the argument changes. And so we don't have the tools to do that. Actually, some of the nice ones were, folks went to the art technology culture talk. Martin and Fernandez showed us Many Eyes, which is a nice kind of really early model to start to build off of. But yeah, I think that, and there's hope for this, right? So if I am talking to you and I say, I got to call you back, I've only got 2 bars. You go, okay. But 15 years ago, you would have said, when'd you buy a bar? I didn't even know you owned a bar. You own 2 bars? So the point is we've entered into bars as part of the vernacular. Everyone understands this weird measurement, bars. So it's certainly reasonable we can have people understand what other quantities of data that we don't readily experience, right? That's just one, this little electromagnetic spectrum, which we all sort of readily talk about as bars. So there'd be other ways for us to converse as a society about it. But you're right, there's a lot of work to still be done. That's why I'm saying, please help. So good, that's a great question. Thank you.
Okay, well, thanks again, Eric, for a great talk.
Great, thank you. Great to be back.